Hi, my name is Marisol Diaz. I'm an assistant professor at Cal Poly Pomona in the Early Childhood Studies Department, and I'm joined by my colleague.
Hi, everybody. I'm Christina Brower, and I'm Early Childhood Education faculty in the Education and Human Development program at Kenyatta College.
So today we're going to share with you an overview of the CSU Early Mathematics COLLAB Modules and how they support meaningful hands-on math learning for young children across PK3. So at the heart of this work is just a shared understanding of why early mathematics matters. We know that early math is much more than just about numbers. It's how children begin to notice patterns, solve problems, reason about space, and make sense of the world around them. Strong early math skills are powerful predictors of later academic success, and they develop best through experiences that are hands on, engaging, and connected to children's everyday lives. The CSU Early Math COLLAB modules are curriculum modules designed to help prepare instructors to deliver research-based, developmentally appropriate, and culturally and linguistically responsive math instruction from preschool through third grade. The modules are aligned with California's early mathematics standards for pre-K ECE educators and the teaching performance expectations, specifically TPE 8. It emphasizes intentional math instruction that is accessible and engaging, and it offers practical ways for pre-K to third grade educators to connect standards to everyday classroom practices. So what's covered? The modules address a full range of foundational mathematical concepts, from early number sense and pattern to geometry, spatial reasoning, and problem solving. Educators learn how to teach these concepts through playful, inquiry-based experiences that encourage children to talk about their thinking, explore materials, and engage deeply with mathematical ideas across learning settings. The modules bring together all the essential building blocks of mathematics, helping children to develop strong skills during the early years that will support their learning over time. So, to show us how these modules are designed to be used in real context, let's take a closer look at how they are structured and applied. Take us away, Christina.
Sure. So let's take a look at what's inside these modules. So in creating the modules, we recognize that curriculum is not a one-size-fits-all approach. The modules are intentionally designed to be flexible and adaptable across contexts. Users can select the content that best fits their instructional goals, learners, and program needs. Each module includes opportunities to introduce key ideas, practice new skills, and assess understanding. So let's take a closer look at the modules and what's included. So on the screen, you'll see how the modules, how the materials are organized and designed to be easy to navigate and ready to use in coursework, professional learning, or collaborative planning. The Early Mathematics COLLAB modules begin with an overview of the content. So I'm going to go ahead and show you all here in comments. So as you can see, if you start here in the modules, you'll see that it begins with an overview of the context, and then goes to future goals and organization of the modules. So there are 8 modules aligned to Standard 8 to support the PK3 mathematics. So as you can see, first here is 8.1, planning and implementing. Then it goes to 8.2, which is learning opportunities and universal design for learning principles. Next up, we have 8.3, which is the learning environment. And then 8.4, children's abilities. Then we go to 8.5, which is differentiation and developmentally appropriate practices. 8.6, observation and interpretation. 8.7 is child-to-child interactions. And then last is 8.8, which is supporting mathematical communication across contexts. And then you can also see that within the learning progression, you'll see that each module, there's an overview of the learning progression. It's organized into 3 categories that are designed to support mastery of the mathematical concepts. So as I shared before, there are 3 categories referred to as learning segments. These are designed to support introducing, practicing, and then assessing. And you can see here at 8.7 how it's done. So for introduce, these are activities that are designed to introduce new mathematic concepts. They're typically used early in a program and are labeled with an I. So you can see here in introduce, there's the I. And then for practice, these activities build on introductory concepts and deepen for understanding. They're commonly used in the middle of a program like an ITEP or early in a post-baccalaureate program and are labeled with a P. So here's you can see practice P. And then last for assess, these activities build on practice experiences and are designed to assess mastery of the concepts. For example, they could be used in upper division or methods courses, or they could be used during student teaching at the end of a program, and these are all labeled with an A. So we can go back here and we can see here that taking a dive into one of these examples to see how this comes to life. So the introduce segment focuses on how young children approach early math concepts, such as number sense, patterns, and problem solving. Users explore how language, cognitive, and social emotional development also influence how children engage with math across preschool through grade 3. So these videos go back here, sorry. Through these videos, readings, and discussions, users connect developmental theory to real classroom practice. The segment includes collaborative planning, where users design developmentally appropriate math activities that build on children's strengths and needs. And then the segment closes with individual reflection, where users consider how developmental levels, equity, and their own math experiences shape their approach to teaching young children. So overall, this chart visually highlights all the early mathematics learning segments that are offered. Introduce, I, practice P, and assess A, and how they are aligned with specific teaching performance expectations that they support. You can really see how the modules work to turn the standards into action, showing how each segment builds from initial exposure to deeper practice and assessment across the mathematics standards. It's a clear path from learning new ideas to using them in practice to help build essential skills that make a real difference for young children. And just as importantly, these same modules are flexible enough to support teaching and learning across different higher education environments, from community colleges to four-year universities. In a community college setting, faculty might use the early mathematics modules within introductory early childhood coursework to connect theory and practice. For example, instructor can use these module activities and classroom scenarios to help students design hands-on math experiences, support children's mathematical thinking, and explore how early math shows up in play and in daily routines. I use these in my courses at the community college. I've used them in practicum courses. I've used it in my curriculum course, but I also see how they can be used in an observation course or principles and practices or child development. Marisol can talk a little bit about how we might be able to use these same concepts in at the university.
Thank you, Christina. So yes, in a university setting, the content from the modules can be used and embedded in various courses, as Christina just shared, along with clinical or field-based experiences. So for example, in my work, I've used some of these modules, not specifically in a math course, but in a literacy course, where students are learning the importance of linguistic diversity and cultural affirmation. And we've used, for example, TP 8.4 to talk about those learning math environments. And the students really love it, and they see the integration part. So these are not necessarily siloed, and they're used to be customizable for instructors to use where they see best. Faculty can use the materials to support deeper analysis of instructional strategies, align coursework with pre-K3 math standards, and help students reflect on how mathematical understanding develops over time. So it's really cool because across both settings, the modules offer a shared foundation, and they provide common language and tools while still allowing for that flexibility to meet the needs of each context and each instructor. And why this all matters? Well, we know that when early math instruction is intentional, engaging, and well scaffolded, all children can actively participate and are set up to succeed. The CSU Early Math COLLAB modules were designed to help children develop strong mathematical foundations through pre-K 3 years and build skills that will support a lifetime of learning. So we invite you to explore, experiment, and make the materials work for your unique needs. Please visit the website to learn more. Thank you.
Everyone, thank you.